In the beginning, there was nothing. No stars, no galaxies, no light, no time itself. Then, in a fraction of a second, everything. A flash of unimaginable energy burst forth from a single, infinitely dense point. And from that moment, the universe began to expand, cool, and evolve into the cosmic tapestry we observe today. This is the story of the Big Bang, not merely a theory, but humanity's best attempt to answer one of the oldest questions. Where did everything come from? Before we get too deep into this topic, be sure to like this video and subscribe to the channel. This helps to bring more valuable content to the platform for your knowledge and understanding. Remember, knowledge is power. Now back to the episode. The Big Bang Theory traces its roots to the early 20th century, a time when most scientists believed in a static, eternal universe. But in 1927, a Belgian priest and physicist named Georges Lemaître challenged this idea. Using Einstein's equations of general relativity, Lemaître proposed that the universe was expanding and must have once been compressed into a single primeval atom, a cosmic egg that exploded to give birth to space and time. Initially, even Albert Einstein resisted the concept, famously telling Lemaître, "Your calculations are correct, but your physics is abominable." But soon, the evidence began to speak louder than theory. In 1929, Edwin Hubble made a discovery that changed everything. By studying the light from distant galaxies through the Mount Wilson Observatory, he found that galaxies were moving away from us, and the farther they were, the faster they were receding. This redshift was clear evidence that the universe was expanding, exactly as Lemaître had predicted. The cosmos, it seemed, was not static, but alive, growing, stretching, and evolving through time. Einstein soon abandoned his idea of a cosmological constant meant to keep the universe stable, calling it his greatest blunder. The age of modern cosmology had begun. If the universe began with an explosion, scientists reasoned, there should still be a faint afterglow, a remnant of that first light. In 1965, radio astronomers Arno Penzias and Robert Wilson accidentally discovered this cosmic microwave background radiation, CMB, while calibrating an antenna in New Jersey. No matter where they pointed their device, they detected a persistent hiss, the cooled remnant of that primordial fireball, still glowing at just 2.7 Kelvin above absolute zero. The discovery earned them the Nobel Prize and gave the Big Bang Theory the confirmation it needed. The universe had a beginning, and that beginning left behind its fingerprint. As our understanding deepened, physicists turned to an even more mysterious chapter, the first 10 to the negative 34th seconds after the Big Bang. In the 1980s, Alan Guth, André Linde, and others proposed the inflationary model, a brief period when the universe expanded faster than the speed of light. This inflation explains why the cosmos appears smooth and uniform across vast distances, despite regions being too far apart to have ever communicated. Inflation also set the stage for the formation of quantum fluctuations, microscopic ripples in the early universe that grew into the galaxies, stars, and planets we see today. The universe, born from quantum uncertainty, carried the seeds of cosmic structure within its earliest moments. About 3 minutes after the Big Bang, the universe cooled enough for the first atomic nuclei to form: hydrogen, helium, and traces of lithium. This process, known as Big Bang nucleosynthesis, provided another powerful piece of evidence. The precise ratios of these light elements matched the predictions of cosmologists almost perfectly. As billions of years passed, gravity pulled matter together into stars, cosmic furnaces that forged heavier elements like carbon, oxygen, and iron. Every atom in your body was once part of a star, or perhaps part of that initial cosmic fireball itself. As the astronomer Carl Sagan famously said, "We are made of star stuff." Fast forward to the present. Today, instruments like the James Webb Space Telescope, JWST, peer deeper into the cosmos than ever before, and further back in time. JWST's infrared eyes have detected galaxies that formed just 300 million years after the Big Bang, challenging previous models of early cosmic evolution. These observations reveal that the early universe was far more dynamic, filled with massive, rapidly forming galaxies and supermassive black holes than scientists once imagined. Meanwhile, experiments like Planck and WMAP have mapped the CMB in exquisite detail, giving us a near-perfect picture of the universe's age, about 13.8 billion years. Each new observation refines our understanding of how the universe evolved from chaos into cosmic order. Yet for all we've learned, vast mysteries remain. Roughly 95% of the universe is composed of dark matter and dark energy, unseen forces that shape the cosmos yet remain almost entirely unknown. Dark energy, in particular, is driving the universe's expansion to accelerate, suggesting that the cosmos might continue stretching forever. Some scientists, like Stephen Hawking, explored whether time itself had a boundary, whether the universe could be finite yet without edges, like the surface of a sphere. Others speculate about multiverses, cyclic models, and quantum gravity frameworks that could unify the Big Bang with the laws of the very small. In this frontier between cosmology and quantum mechanics, the birth of the universe remains the greatest unsolved riddle. Today's cosmologists are explorers of time itself, probing the universe's infancy through simulations, telescopes, and particle accelerators. Projects like the Large Hadron Collider test conditions, similar to those just moments after the Big Bang. New observatories track gravitational waves, ripples in spacetime, to glimpse events that shaped the early cosmos. The future of cosmology may bring us closer to answering whether the universe had a true beginning, or whether it is part of something even grander, an eternal cycle of birth, death, and rebirth. As our instruments grow sharper and our imagination deeper, we continue to look back toward the very first light. From a single spark of creation to galaxies stretching across billions of light years, the Big Bang reminds us that everything, space, time, and life itself, emerged from one miraculous beginning. And in that story of creation, we find our own. If you found this content helpful, don't forget to like this video and subscribe to the channel. Leave me a comment. Let me know what you think about the Big Bang Theory and the ever-expanding universe. Join me next time for another deep dive into the mysteries of the cosmos.